This is a method used to find the derivative of a function. Derivatives of a function represents the rate at which the function's output changes with respect to its input. For example, the derivative of f of x is written as f phi of s. Also, it can be written as dy dx. So this is the symbol we use to represent a function that has been differentiated. This is one of the formula we use to find the differentiation from first principle. It is given as f open bracket s plus h minus f of s over h as h tends to 0. For us to use this formula, we have 4 steps. The first step is to substitute f of s into the formula. It means that wherever you see x, x becomes x plus h. Where you have 2x, for example, it becomes 2 brackets open x plus h. So wherever you see, for example, we have x squared becomes x plus h all squared. So if, for example, the function is x, it means that our s becomes s plus h. If, for example, the function is 2x, this becomes 2 open bracket s plus h. If, for example, the function is x squared, this becomes s plus h all squared. Step 2 is to expand this function right here. We expand this function right here in the numerator. Then step 3 is to simplify the numerator, or you factorize or you cancel h with the denominator. Then the last step is to evaluate the remaining expressions as h tends to 0. I will show us 2 examples of how we can use this formula to differentiate from first principle. Here is our first question. We're asked to differentiate f of s. So we have f of x equal to 2x. So how do we do this? Remember, our formula is f phi of x is equal to, we have the limit as h tends to 0, f x plus h minus f of x over h. So this is our formula. Remember, I said earlier on that if you have 2x, 2x becomes, or 2x becomes 2 open bracket x plus h. So therefore, this equation becomes 2 times x plus h. So therefore we have our limit. So we replace this with this. So we now have 2 open bracket x plus h minus our f of x is 2x. So which is 2x over h. This is step 1. Step 2 is to expand or simplify this numerator. So what we do is that these 2, we multiply everything in this bracket, then we can simplify. So let's continue. So we have our limit. As h tends to 0. So here we have 2 times x is 2x. 2 times plus h is plus 2h minus 2x all over h. So the step 3 is for us to simplify this equation. So again, here we have 2x, we have 2x. What we do is to group like terms. So I can say, therefore, we have our limit as h tends to 0. So we have 2x minus 2x. So I will group it. So we have 2x minus 2x plus 2h over h. So 2x minus 2x is 0. So we're left with 2h. So therefore we have limit h tends to 0. So we have 2h over h. What next? We can cancel h. So what we are left with is just what? 2. So therefore, the differentiation of f of x equal to 2x is 2. So this is our answer. Here is the next question. We're asked to differentiate f of x is equal to 2x squared. Again, our equation is f prime of x is equal to the limit h tends to 0, f open bracket s plus h minus f of x over h. So right now, remember that 2x squared 2x squared is same as saying 2 open bracket s becomes s plus h squared or squared. So what we do now is to replace this equation, this equation right here, with this. So we now have limit h tends to 0. So this becomes this. So this is equal to f of s plus h. So therefore we have 2 open bracket s plus h or squared minus f of x over h. Right. So our next step is to expand this equation. Now we have x plus h squared. For you to expand this, you have to be familiar with your binomial theorem. If you want us to show you how to solve binomial theorem, leave a comment in the section, leave a comment below, and we shall make a video on binomial theorem. But to do this now, we can just expound on this. So s plus h all squared, s plus h all squared is same as saying x plus h times x plus h. All right. So x times x is x squared plus x times plus h is xh plus h times x is plus xh plus h times h is h squared. So therefore, we have x squared plus sh plus sh is 2sh plus h squared. So therefore, s plus h all squared gives us this. So I will replace this with this. So therefore, we have our limit as h tends to 0 is equal to 2 open bracket. This is this. So we have s squared plus 2xh plus h squared minus f of x is same as saying 2x squared. Remember in the question, we are given that f of x is 2x squared. So our f of x is 2x squared over h. So what next is for us to simplify the numerator by multiplying everything in the bracket by 2. So our next step limit as h tends to 0 is equal to 2 times x squared is 2x squared. 2 times plus 2sh is plus 4sh, and 2 times plus h squared is plus 2h squared minus 2x squared over h. So the next thing we do here, the next thing we do here is to simplify the numerator. As you can see, we have 2s squared here, and we have 2s minus 2s squared here. That means that what we do now is to group. So what we do is we'll collect the similar terms, and we have 2x squared, we have 2s squared. So we can say therefore we have our limit as h tends to 0 is what? We have 2s squared minus 2s squared. So we have 2s squared minus 2x squared plus 4sh plus 2h squared over h. Now, our next step is step 3 is to simplify the numerator. Now, as you can see, 2s squared minus 2s squared is gone. That's 0. So we're left with 4sh plus 2h squared over h. So again, therefore we have our limit as h tends to 0 is 4sh plus 2h squared over h. We can factorize the numerator. So we have what? We have our limit as h tends to 0. So we have h, so I'll take 1. So I will have h open bracket, h divide 4sh, that will give us 4x, plus h divide 2h squared, that will give us 2h. So I just factorize the numerator over h. If you want to learn how to factorize, let me know in the comment section and we shall make a video on factorization. So now we have h, so h cancel h. So we're left with limit h tends to 0. We have left with 4x plus 2h. Now, since we still have h in the equation, we can substitute h for 0. Remember, the limit here means that as h tends to 0. So if h is equal to 0, so therefore we have what? We now have 4x plus 2, h is 0. So that gives us 4s is 4s, 2 times 0 is 0. So our answer is 4s. So the derivative of 2x squared is 4s. We have to find the derivative of f of s equal to 2s plus 1 using differentiation from first principle. What we do again, remember our formula is the limit or is limit as h tends to 0, f of x plus h minus f of x over h. All right. So remember again, what you have right here should be f of phi of x equal to. So this is our given function. And please remember that we have 2x plus 1, 2x plus 1, 2x is the same as saying 2 open brackets, x plus 1, that's it. Then plus 1, so we have 2x plus 1 becomes 2 open brackets, x becomes x plus h, sorry, here should be h plus 1 plus 1. So this equation is equal to f of sh plus 1. So this is equal to f of s plus h. So we have to replace this whole equation by this. And f of x is 2x plus 1. So therefore, our equation becomes limits of as age tends to 0. So I will replace this, with 2 open brackets s plus h plus 1 minus f of x is this, which is 2x plus 1. So it's 2x plus 1 over h. So the next step is to simplify the numerator. So therefore we have limit as h tends to 0. 2 times x is 2x. 2 times plus h is 2h plus 2h plus 1 minus 2x plus 1. 2x plus 1 over h. So the next step here is to further simplify the numerator. As you can see, we have like terms. For example, we have 2x, we have 1, and we have plus 1. So what we do next is to simplify further the numerator. So what we do is to group like terms. So we have limits as age tends to 0. So we have 2x minus 2x. So we have 2x minus 2x. We have plus h. We have plus 2h plus 2h. Then we have plus 1. We have plus 1. Minus plus is a minus. So we have minus 1. Minus 1. So over h. As you can see, 2s minus 2s gives us 0. Plus 1 minus 1 gives us 0. So we are left with 2h over h. So therefore we have limits as h tends to 0. We have 2h over h. Here h cancel h. So we are left with 2. So this is our final answer. So therefore we can say that the derivative of 2x plus 1 is equal to 2. So 2 is the derivative of 2x plus 1. Let's look at our next question. Here we're asked to find the derivative of 3x squared plus 2x plus 1. Again, remember the formula is f prime of x is equal to the limit as h tends to 0, f of x plus h minus f of x over h. Now, we have to work on this right here. So, 3x squared, remember guys, 3x squared plus 2x plus 1 can be written as 3. S becomes x plus h or squared plus 2. 2, s becomes x plus h, then plus 1. This new equation is equal to f of x plus h. So what we do is to replace this equation with this. So therefore, we have limits as h tends to 0. I will place this equation right here with this. So we have 3 open brackets s plus h or squared plus 2 times x plus h plus 1 minus f of x is 3x squared plus 2s plus 1. So it's 3x squared plus 2x plus 1 over h. We missed our last video. To expand s plus h squared, what we do is to s plus h squared is equal to s plus h times x plus h. So s times x is x squared, x times h is plus xh, plus h times x is plus xh, plus h times plus h is plus h squared. So we have x squared plus sh plus sh is 2sh plus h squared. So s plus h all squared is equal to s squared plus 3sh plus h squared. So I will replace this, whole equation with s squared plus 2sh plus h. So therefore, we have limits as h tends to 0. We have 3 open bracket. Replace s plus h all squared with x squared plus 2sh plus h squared plus 2s plus h plus 1 minus 3x squared plus 2x plus 1 over h. So what we do next is to open up this bracket, or we can say we have to simplify further what we have in the bracket. So we now have limit as h tends to 0. 3 times s squared is 3s squared. 3 times plus 2sh is 6sh is plus 6sh. 3 times plus h squared is plus 3h squared plus 2 times x is 2x times plus 2 times plus h is plus 2h. Then we have plus 1. Now, this minus, we multiply everything on the right. So minus 3s squared, here we have minus 3s squared. Minus times plus is minus, so we have minus 2x. Minus times plus is minus 1. If you want to know how to multiply signs, you can please click on the link on the card above so you can learn how to do that. So over h. So the next step now is to further simplify the numerator by grouping the like terms. As you can see, we have 3s squared here, we have 3s squared here, we have plus 2x, we have minus 2x. So we have to group the like terms. So we have limit as h tends to 0. So we have 3x squared minus 3s squared. This is called grouping. Then we have plus 2x minus 2x. So we have plus 2x minus 2x. Again, we have 6 plus 6sh. We have plus 3h squared. We have plus 2h. We have plus 1. We have minus 1 over h. This, what I've just done on the numerator, is called grouping of like terms. If you want to learn how to group like terms, you can leave a comment in the section below and I will make a video on that. So 3s squared minus 3s squared, this gives us 0, plus 2x minus 2x is 0, plus 1 minus 1 is 0. So what we have on our numerator is 6sh plus 3h squared plus 2h over h. So therefore, we have limits as h tends to 0. We have 6sh plus 3h squared plus 2h over h. Now, what we can do here is to simplify the numerator, or let me say we can factorize. As you can see, we have h on each term, so I can bring out h and open bracket. H divide 6sh is 6x plus h divide 3h squared is 3h plus h divides 2h is 2 over h. As you can see right here, h cancel h. So what we have left is limit as h tends to 0 is we have 6x plus 3h plus 2. Now, our last step in doing this is to substitute h for 0. So if h is equal to 0, so we have 6x plus 3 times h is 0 plus 2. So that gives us 6x plus 3 times 0 is 0, so we have plus 2. 3 times 0 is 0, so we have plus 2. So therefore, the differentiation of 3x squared plus 2x plus 1 is equal to 6x plus 2. So this is our final answer. Polynomials is of this form: y equal to s to the power n. First, to differentiate this, it becomes dy over dx. This means that we are differentiating y with respect to x. So the formula we use to differentiate is the index, which is the power, becomes the coefficient. So we have n times the x times the x, then the n, which is the new index, is 1 less than the index in the original power. So it becomes n minus 1. So this is the formula or the format we use when we are differentiating polynomials. Remember, the index, which is the power, becomes the coefficient, and the new index is 1 less than the original power. Now, how do we differentiate a constant? For example, we have y is equal to c. First, to differentiate this is dy dx. So we're asked to differentiate y with respect to x. And as you can see on my right hand side here, we have no x value on my right hand side. So that means that this is a constant. So to differentiate a constant will give us 0 because it has no x value. Remember, we are differentiating y with respect to x, and there's no x value on this, so it is 0. Again, if for example we have y equal to 2, again the y, the x will give us just 0 because there's no x value in 2. So to differentiate a constant gives us 0. What about if y is equal to x? In this case, we can differentiate. So it means that we have dy over dx equal to x. So remember that x on its own means that it has power of 1. So it means that, remember the formula, it means that the index becomes the coefficient. So we have 1 times x. The new index is less than 1. So we have 1 minus 1. So that gives us 1 times x. 1 minus 1 is 0. So we have 1 times x to the power 0 is 1. So 1 times 1 is equal to 1. So therefore, it means that when we differentiate x with respect to the x, it gives us 1. All right. Here is a question. For us to differentiate polynomials, we have to differentiate each term in turn. For example, we have to differentiate this separately, separately, and separately. So if y is equal to 2x to the power 5 plus 4x to the power 4 minus x cubed plus 3x squared plus 7, find dy dx. Dy dx means that we are asked to differentiate the right hand side of y with respect to x. So it means that we have dy over dx equal to, let's start with the first term. This is the first term. So the power becomes the index, so it's 5 times 2. So we have 5 times 2. Then x becomes what? 5 minus 1 plus, we have 4 times 4. Then x equal to what? 4 minus 1 minus, remember, 3 times x, then 3 minus 1 plus 3 x squared, which is 2 times 3 x 2 minus 1 plus, remember, 7 is a constant, so to differentiate a constant gives us 0. So let's continue. So 5 times 2 is 10, so we have 10 x 5 minus 1 is 4 plus 4 times 4 is 16 x 4 minus 1 is 3 minus 3 x 3 minus 1 is 2 plus 2 times 3 is 6 x 2 minus 1 is 1 plus 0. So this is our final answer. So the differentiation, or differentiating y with respect to x, gives us 10x to the power 4 plus 16x cubed minus 3x squared plus 16x. So again, the key is to remember the format is the power becomes the coefficient, then the new power is always less than the index in the original power. Let's look at the next example. This time we're asked to, if y is 6x cubed minus 7x squared plus 4x plus 5, find the y dx and the value of the y dx when x is 3. So what they're asking us here is first to differentiate y, then secondly, first we differentiate y, then second we substitute x for 3. So let's do the first part. Let's differentiate y. So our dy dx is, so again, the power becomes the coefficient, so we have 3 times 6, so we have 3 times 6, so x, we have 3 minus 1 minus 2 times 7, 2 times 7, then x, so 2 minus 1 plus x, so what we have here is 1, this is 1, so 1 times 4, so become x comes 1 minus 1 plus, when we differentiate 5, 5 is a constant, so that gives us 0. So therefore, our dy dx is equal to 3 times 6 is 18 x 3 minus 1 is 2, minus 2 times 7 is 14, x, 2 minus 1 is 1, plus 1 times 4 is 4, 1 minus 1 is 0. So x, 1 minus 1 is 0. Okay, so therefore our dy dx is equal to 18x squared minus 14x plus 4. Remember that x to power 0 is 1. Remember that x to power 0 is 1. So 4 times 1 is 4. This is our first part of the question. Remember, we're asked to find the value of dy dx when x is 3. So if x is equal to 3, so therefore we have our dy dx becomes 18, x is 3, so we have 3 all squared minus 14 times x is 3 plus 4. So that gives us 18 times 3 squared is 3 times 3, that gives us 9, minus 14 times 3 plus 4. That will give us 18 times 3 is 162, minus 14 times 3 is 42 plus 4. So 162 minus 42 plus 4, that gives us 124. So this is our final answer when x is 3. Second derivative is when we are differentiating a polynomial more than once. For example, we represent the derivative in this form: d squared y over dx squared. This means that we are differentiating twice. When we have dy over dx, it means that we are differentiating once. Also, we can also be asked to differentiate a polynomial more than twice. For example, 3 times, and it is written in this form: d cube y over ds cube. So this is when we are differentiating 3 times. So let's look at a question. Here is a given question. We're asked to differentiate y equal to 3x to power 4 plus 2x to power 3 minus 4x squared plus 5x plus 1. Find the squared y over the s squared and the cube y over the s cube. So we're asked to differentiate first, to differentiate twice, and to differentiate the third time to get this. So let's start with our differentiation. Remember, our given polynomial is y equal to 3x to power 4 plus 2x cubed minus 4x squared plus 5x plus 1. So to differentiate once, we use dy over dx. So to differentiate this term, remember, to differentiate a polynomial, we differentiate each term. So we differentiate 3x to the power 4, we differentiate the next term, the next term, and the next term. So to differentiate this first term is, remember, is the power times the coefficient. So we have 4 times 3x, then 4 minus 1. If you missed our first video on calculus, please click the link on the top right corner so you can understand what we are doing right here. Plus, again, the power times coefficient. So we have 3 times 2x, then the power minus 1. Minus 2 times 4, we have 2 times 4x 2 minus 1 plus, remember that 5x has a power of 1 here, so we can say 1 times 5x 1 minus 1 plus, when we are differentiating a constant which is 1, it becomes what? 0. So our first differentiation is 4 times 3 is 12, x 4 minus 1 is 3, plus 2 times 3 is 6, x 3 minus 1 is 2, minus 2 times 4 is 8, x 2 minus 1 is 1, plus 1 times 5 is 5, x, now x 1 minus 1 is 0, and s to the 0 is equal to 1. So 1 times 5 is 5, plus 0 is 0. Okay, so this is our first derivation. The question is for us to differentiate it twice. So therefore, we have to differentiate again. So this squared y over the x squared will give us, again, the power times the coefficient. So we have 3 times 12x, then the power minus 1, plus 2 times 6, 2 times 6x, 2 minus 1, minus 8. Remember, guys, that here is power 1, so it's 1 times 8x, then 1 minus 1, plus, now 5 is a constant, that gives us what? 0. So when we are differentiating a constant, it gives us 0. So therefore, our differentiation, the square y over the x squared, will give us 3 times 12 is 24. Sorry, 3 times 12 is 36. X 3 minus 1 is 2, plus 2 times 6 is 12, x 2 minus 1 is 1, minus 1 times 8 is 8. Again, remember, x 1 minus 1 is 0, s to power 0 is 1. So this gives us 8. So this is our second derivative of the given polynomial. So to differentiate a third time, that means we have to differentiate this function again. So we have the cube y over the x cube equal to, again, the power times coefficient. So we have 2 times 36 x, 2 minus 1. So we have 2 minus 1, plus, this is power 1. So 1 times 12x, again 1 minus 1, minus 8 is a constant. When we differentiating a constant, we get what? 0. So therefore, differentiating the third time will give us what? That gives us 2 times 36 is 72x. 2 minus 1 is 1, plus 1 times 12 is 12. X, remember again, x 1 minus 1 is 0. So x to 0 is what? Is 1. So that gives us what? 12. So differentiating the polynomial 3 times gives us 72x plus 12. And differentiating it twice gives us 36x squared plus 12x minus 8. So this is how we solve second and higher derivative.